Hiya. Here we are in June 2020 now with AQA once again. This is question 12. It's a 13 marker broken into four pieces. The first bit is pretty straightforward. We've got this implicit function in terms of x and y with some trig values, some trig functions thrown in. And we're told one of the points is √3 and pi upon 6. We are asked to prove that the value of a, the coefficient in front of x on the right hand side, is equal to 2. So it's just a case of plugging stuff in at this point. So we're plugging in √3 in place of x, so x cubed is √3 cubed sine pi upon 6 plus cos pi upon 6 equals √3a. Okay. So all we're going to do now is obviously this is a calculator paper, but these are known trig values. So √3 cubed is √3, so that becomes 3√3 times sine pi over 6 is a half, and plus √3 upon 2 equals √3a. So this, I'm going to multiply everything through by 2 actually. So I end up with 3√3 plus √3 equals √3, 2√3a. Okay, and we end up with 4√3 on that side equals 2√3a. And conveniently, our √3's cancel, so a is equal to 2. So there's our first basic 2 marks. Okay, now I'm going to move on to the more difficult bit. So part 2, this is the 5 marker, so obviously quite significant. We are now asked to find the derivative of our implicit function, but rather asked us to prove specifically what that derivative is. Notice here we have a product, okay, an implicit product, i.e. there's x's and y's put together. So I can basically use the product rule, so I can multiply x cubed by the derivative of sine y, sine differentiates to cos y dy dx, plus the derivative of x cubed, which is 3x squared sine y, multiplied by sine y. Cos goes to negative sine y dy by dx, differentiate in terms of y, equals 2. Okay, so first bit done. Now we just need to collect our dy dx's together. So we end up with x cubed cos y dy by dx minus sine y dy by dx equals 2. I'm going to subtract this term 3x squared sine y. Okay, now it's just a basic process of taking out our factor of dy by dx. We end up with cos y, sorry, I nearly forgot my x cubed, cos y minus sine y equals 2 minus 3x squared sine y. And finally, it's time to just divide both sides through by our bit in the square brackets, giving us dy by dx equals 2 minus 3x squared sine y over x cubed cos y minus sine y. And there is 5 marks because we were asked to prove precisely that. Okay, second bit done. So part 3, we have now got the derivative dy by dx in terms of x's and y's, and we're actually asked to find the numerical value of the gradient at point P. So again, just a case of plugging √3 and pi over 6 in the correct places. So dy by dx is equal to 2 minus 3 lots of √3 squared sine pi by 6, all divided by √3 cubed cos pi by 6 minus, sine pi by 6. Okay, so once again, we could just plug this into our calculator. I'm not a big fan of doing that. I just enjoy making things neater in my own head. So √3 squared is going to be 3, so that's going to be 9. Sine pi upon 6 is a half, so that's 9 over 2. All over, that's going to be 3√3, which we did before, times cos pi upon 6, which is going to be √3 upon 2. and that's going to be sine pi upon 6, which is minus a half. Okay, so it looks a bit ugly, but the root 3's will go. I can multiply everything through by 2, so I end up with 4 minus 9 on the top. Obviously divide by 2's go, that just becomes 3 times 3, which is 9, minus 1, so it's equal to negative 5 over 8. So there's another 2 marks. We're starting to rack them up now. Part 3. So part 3 done. Part 4. This is only worth 2 marks, but obviously we're racking them up now, and this is going to be the full 13. So what we're after is we're after the equation of the tangent to the point on the curve at point P. So we know the gradient now from the derivative, 5/8 x plus c, and we're going to sub in our value of P. So our y value is pi over 6 equals negative 5 root 3 upon 8 plus c. Oops, a little nicer. Okay, so obviously rearranging that, we're going to get c is equal to pi by 6 plus 5 root 3 upon 8, and 6 and 8 both have a common multiple of 24, so that becomes 4 pi plus 15 root 3 on 24. So we now have our equation in its full form. Y equals minus 5/8 x plus this rather odd looking intercept 4 pi plus 15 root 3 all on 24. Okay, so we're not after the x, the intercept of the y-axis, i.e. the constant. We're actually after the intercept on the x-axis. So for that reason, we have to set y equals 0. So we end up with 0 equals negative 5/8 x plus our constant, which I'm going to have to write out again in its full glory, over 24. I'm going to add 5x to both sides, 5/8 x to both sides, so I get 5/8 x equals this long old business again. And same way I'm going to write it all out again. I'm just going to change my denominator on the left, multiply top and bottom by 3. I get 15 over 24x, and of course I can multiply both sides by 24, and then I can divide by 15, so I get x equals 4 pi upon 15 plus 15 root 3 over 15, which is root 3. Okay, so there's our x-intercept, and there is our final 2 marks of this 30 mark Leviathan. Okay, thanks.